Hello folks, let's come to the part 5 video of this exercise 1.3, and we're continuing with what we were doing last time. Very interesting about invertible functions, and we had said that for saying that a function f is invertible, we will show that fog of x is x and gof of x is x, and that's how it becomes invertible. There is also another way of showing invertible, that a function f is invertible. The alternative method is you show that f is 1 to 1 and show that f is onto. That means f is bijective. So when f is bijective, also f is invertible. That is also one of the ways of showing it, but somehow I feel that it's a bit more of work, but that's also correct method. You'll see many books following that method. Both ways are correct. So this is how we were showing, and we're continuing with that very interesting exercise as to how we can get this invertibleness. 10th question says that f from x to y is invertible function. You have got to show that it has a unique inverse. That exclamatory mark is a symbol for unique. So it has a unique inverse you have to show. So it's been already hinted in the question itself that you take two functions, and because we're kind of taking contradiction, like it's not unique, there are two functions, and then get across a contradiction, and then that's how. So let's start right away. Let if possible. Yeah, let if possible. There exists two inverses g1 comma g2 from y to x such that g1 of at x equal to x and f1 og at x is x. Also g2 of at x is x and fog2. That's how we get the inverse. Now let's consider fog1 at x is x and fog2 of x is x. See, the right hand sides are equal, so left hand sides will be equal. So fog1 of x is fog2 of x. By definition, this is f of g1 of x, f of g2 of x. Now f is an invertible function. If it's an invertible function, automatically it is 1 to 1. It's bijective, and that way it is 1 to 1. If it is 1 to 1, we all know that f of x1 equal to f of x2 will always imply x1 equal to x2. That means whatever comes after f in the brackets, they will get equal. That's because they are 1 to 1. That way you will get g1x equal to g2x. Reason is because f is 1 to 1. Right. So that's it. We have taken two different functions g1 and g2, but they have come up to be equal. We have showed that it is equal. So it's a contradiction. Why this contradiction has come? Because we have made a wrong assumption. So but g1, g2 were assumed to be two different functions. Therefore, there is a contradiction. This contradiction arose since our assumption was wrong. Therefore, f has a unique inverse. We're done with that, right? That is our problem number 10. Now we'll quickly move to problem number 11, which says that they have that's quite interesting because it's like very pictorial. You can do the picture part and you'll get it. You already have the f defined from 1 to 3 to ABC, and let's see how it is defined. This is 11th problem. You have this f here already defined. The function f is defined from 1, 2, 3 to A, B, C. How? 1 goes to A, 2 goes to B, and 3 goes to C. This is how it is defined. Find F inverse. F inverse means what? That this function should come back to A. That means, see, you have to define F inverse, means from where it started, there only it should come. A should come to 1, B should come to 2, C should come to 3. That is F inverse. So find F inverse. Therefore, F inverse is equal to A1, B2 and C3. Yeah, here let's check. See, if you check, F from 1 coming back to 1, 2 coming back to 2, 3 coming back to 3. Okay, so that is the F inverse definition. Find F inverse. So we found the F inverse. Because we have done it pictorially, we could do it really fast. Otherwise, sometimes it would take little time. So that is F inverse. Then they ask us to show that F inverse of inverse is F. So you have already got F inverse. Now again you take the F inverse. F inverse of inverse. So that means you want another function. Yeah, we'll take F inverse of inverse. F inverse of inverse means what? From this has to come back to A, B and C. So 1 should come to A, 2 should come to B and 3 should come to C. F inverse of inverse should be like 1 coming to A, 2 coming to B and 3 coming to C. How do you get that? You will just see, from where it is coming, it should come back there. So like that we have this way. And they ask us, show that F inverse of inverse is F. Yeah, when we look at the function F, it's the same. 1 going to A, 2 going to B and 3 going to C. Yeah, therefore F inverse of inverse is F. Right? So first what we did is, we had 1 going to A. When we have to find the inverse, A should come back to 1. When we have to find the inverse, B should go to 2 and C should come to 3. Fine, we are done with F inverse. Now once we did F inverse, it was asked to find F inverse of inverse. So you should look at the function F inverse and see the all the pre-images, and you should get the pre-image. So you should get A, should get B, you should get C. So like that, or it's like a journey behind. You have the journey back, have the journey back, have the journey back. That way also you can get it. So this is your F inverse. If F inverse of F is F from the elements that we have listed. From the elements listed from the above arrow diagram. Right. Now let's see the question number 12. What does it say? That function f from x to y is invertible. It's an invertible function. We have got to show that in general. Now here in particular we had found out that f inverse of inverse is f. Now they say in general you find out that for any function f which is invertible, f inverse of inverse is going to be f. So how do we go about doing it? So let's start. Let us call g from y to x. Let g from y to x be such that g is f inverse. We are going to call this f inverse. Every time calling f inverse is difficult, so we will call g as f inverse. Now what do you have to show? To show that according to what is given in the question, g inverse is f. That's what you need to show. You have to show that g inverse is f. So for that we will consider f o g of x, that is f of g of x, or rather it is f of f inverse of x. So f o, that means f o f inverse. F o f inverse is always identity, so that will be x. And let's consider g o f of x. So g o f of x means g of f of x. That means f inverse of f of x actually. So that is identity x. Therefore you will have thus f o g of x is x and g o f of x is x. So therefore g inverse is f. That's the meaning. Yeah, whenever we have it coming back to x, one of the ones inverse will be the other. That's how, whatever way you want, whatever is suitable to you. So here it's very clear that g inverse is f. But g inverse we know is f inverse of inverse. Right? So that is why it is f. That's how it is coming to f. So that's what they have asked us in the question number 12. This is our part 5 video. In the part 6 video we have 2 MCQs left. So we will be doing the MCQ, and that's how we wind up the exercise. Thank you.